Here we have a multivariate expression. That means that we've got more than one unknown variable. We've got x, which is an unknown variable, y, which is an unknown variable, and w, which is an unknown variable. I like this question because it's going to bring us back to our exponent rules. Remember, our exponents rules said that if we have x a divided by x b, that's equal to x a minus b. And if we have x a times x b, that's going to be equal to x a plus b. And notice that the base is the same. To make this look a little bit clearer, I can divvy it up. So I can write this as 4y squared divided by 4w y cubed plus 8x to the 6 y to the 5 divided by 4w y to the 3. And I can do that just to make it a little bit easier to look at. And if I do that, I get the 4's, those just divide into 1. I'm going to get y 6 minus 3 over w plus 2 x to the 6 y 5 minus 3 over w. And simplifying a little bit, I'm going to have y3 plus 2x6 y2, and that whole thing over w. Just brought the denominator together. And I can go a little bit further. I could factor out a y2. So I've got y plus 2x6 over w. Yeah, the question is asking us to simplify, so we want to simplify it as much as possible. So here I am on ALEK's. I'm going to plug in our simplification. So we have y squared, and then a bracket, y plus 2x to the power of 6. Oh, and I'll hit right. Oh, and make sure I get my brackets looking as correct as possible. And then maybe I'll highlight this whole thing. Then I'm going to hit this button here and create a fraction for our w. And if I do that and I click on the check button, let's see if we get the right answer. And we did. So we simplified it as much as possible, and we use those exponent rules that I just showed you. We're asked to simplify the following expression. One thing that makes this expression easier to simplify is that in the numerator, the denominator is already in its lowest common denominator form. That's the 3x right here. And similarly in the denominator, it's already in its lowest common denominator form. Since that is the case, I'm going to start by putting it from its division form into its multiplicative form. So we're going to have the numerator remaining the same, and it's going to be multiplied by the flipped denominator. So we're going to have 4x cubed in the numerator and 15 minus 5x in the denominator. I see lots of things that we can do here to make this simpler, make this expression simpler. One thing, notice that in this numerator here, what can I do with that? Well, I can use or write it in the difference of squares formula, like that. We'll see what happens. We'll see what happens there. Maybe actually what I'll do is I'll just take the difference of squares right away. So we've got 3 minus x and 3 plus x like that. And notice that I've got an x here and 3 x's over there. So I could just rewrite this as 3 and 4x squared up there. And then with the denominator down here, I've got a 5 and a 15. So I can factor out 5, and I'm left with 3 minus x. Now we can see that this 3 minus x here and this 3 minus x there, they're going to cancel out. And we're going to be left with 3 plus x over 3 times 4x squared over 5. Well, the last thing I think we can do is we could write this as 4x squared 3 plus x. So I haven't actually changed the numerator. I've just moved one factor to the left. And then the denominator, 3 times 5, that's 15. And I don't think we can simplify it any further. So why don't we put this into ALEKS and see if we have the right answer. So here we are in ALEKS. I'm going to enter the answer that we came up with. I've got 4x squared and create a bracket, 3 plus x. And then I'm going to highlight this whole thing, press this button over here, the square, with a line below it, and then another square below that line, and type in 15. I'll click the check button, and we simplified this expression. Let's try some polynomial long division. Now, it's going to be a lot like the long division you may remember from grade school. I'm going to write 3x minus 2, this term here, and I'm going to put one of these little tables like that. And I'm going to write the entire numerator inside it. And this is what's called an algorithm. So this is just an algorithm. It doesn't have any, there is no intuition why it works. It just works. It's an algorithm. It's like, when we think algorithms, we think of computer programs. We do it because it works. And so if I want to know how many times the polynomial 3x minus 2 goes into this larger, higher order polynomial, then I start by looking at the first term, this 3x minus 2, and I ask myself, how many times does 3x go into 12x cubed? And so I'm basically saying, well, what's 12x 3 over 3x? Well, it's equal to 4x squared. So I'm going to write, well, I'll write it up here, 4x squared. Now I'm going to multiply this 4x squared by the first term and the second term. And so I'm going to get, and remember we negative, so I got negative 12x cubed minus 8x squared, but that's a minus, and so it's going to be a plus, because it's minus a minus is a plus. I draw a bar like that. As we always want, 12x cubed minus 12x cubed is 0. Now I've got this negative 23, oh, excuse me, I didn't write it correctly. I should write it as x squared like that. Plus 8, that's going to give us minus 15x squared. Now, how many times does 3x go into negative 15x squared? Well, I'll write up here, I'll say negative 15x divided by 3x. Well, that's going to be negative 5x. So I'll write negative 5x up here, negative 5x multiplied by this thing. No, I better not. I don't want to forget my negative sign. I'm going to get plus 15x, because a negative and a negative is a plus. That gives me 0. What about the next term? I've got negative 5x multiplied by negative 2. So I've got a negative and a negative and a negative. So that's going to give me negative 10x. Oh, I wrote in the wrong space, excuse me. Negative 10x. And now I want to know what 4x minus 10x is equal to. Well, that's going to be equal to negative 6. How many times does 3x go into negative 6? Well, it goes in there negative 2 times. So I'll write a negative 2 up here. Now I've got negative 2 times 3x, so that's plus 6x. What about the last term? I've got negative 2 times negative 2 minus, so a minus, a minus, and a minus is a minus. So I'm going to have minus 4. And plus 1 minus 4 is equal to minus 3. Now how many times does 3x go into 3x? Well, we're going to say 0 times. And this here is going to be our remainder. And I'm going to call this thing here our quotient. So let's plug these answers into ALEK and see if we got the right answer. Here we are on ALEK. 4x squared minus 5x minus 2. And our remainder is minus 3. So I'll click the check button and let's see if I did it correctly. And I did. Would have been very easy for me to make a sign error, so I'm a little bit relieved to see the correct button, correct icon, but we did it. So our next question is asking us to solve for y. Normally I would like to start with a lowest common denominator, but I'm going to approach this slightly differently because I see I've got this y plus 1 and I'd like to move it. So I'm going to multiply both sides of this expression by y plus 1. When I do that, we get negative 6 is equal to negative 6 times y plus 1 minus y plus 1 over y minus 1. Why did I do that? Well, now it's very obvious to me what I need to do to find the lowest common denominator here. If I multiply these two terms by y minus 1, all the terms will have the same denominator. So why don't I go ahead and do that? When I multiply the numerator and denominator of these two by y minus 1, I get negative 6 y minus 1 over y minus 1 is equal to negative 6 y plus 1 times y negative 1 over y negative 1 minus y plus 1 y minus 1. And now that they all have the same denominator, I can get rid of them by multiplying this whole expression, both sides, by y minus 1. So we've got negative 6 y minus 1 is equal to negative 6 y plus 1 y minus 1 minus y plus 1. Now it might not be obvious how to proceed. If I look at each of the terms, there are no common factors. So we've got a y plus 1 over here, and a y plus 1 over here, but there's no y plus 1 over there. So what I'm going to do is I'm going to open up the brackets. I'm going to multiply through the brackets, and after I do that, I'm going to collect like terms. So let's get started. We've got negative 6y plus 1. And then here I've got negative 6 multiplied by, well, that's a difference of squares. I know that's going to be y squared minus 1 minus y minus 1. And there's a hint in the question, which is that we're doing quadratic factoring. And so I'm going to set this question up as a quadratic equation, which means it should be equal to 0. So I'm going to move all the terms to the right-hand side. So I haven't finished. I'm going to open this bracket. So I've got 6y squared plus 6 minus y minus 1. And then I'm going to move these over, so I get plus 6y minus 1. And I can see right away that I've made a mistake. I made a mistake. What mistake did I make? I was going too quickly, and that should have been a plus 6. So I want to have a negative 6 over here. Now let me collect like terms. So there's only one y squared term, so we have negative 6y squared. The 6 minus 6 is equal to 0. And I'm going to be left with plus 5y minus 1. And this whole thing, of course, is equal to 0. Now the question is asking us to solve for y. And now that we've got it in its quadratic form, if we can factor it, or if we use the quadratic equation, we can find the solution for y. Now we probably suspect how many solutions are there going to be for a quadratic equation? Typically there's 2. There's going to be 2 answers for y. So looking at this expression, I want to factor it. I always find it challenging to factor an expression if the coefficient in front of the square term is not 1. And in this case it's negative 6. So I can look at it, I can play around with it, I can do some trial and error to get the right answer, but you also might want to use the quadratic formula. To remind you, the quadratic formula says that y is going to be equal to negative b plus minus the square root of b squared. I got rid of that minus sign in front of the b, and I've added the equation right there. So you could use this quadratic formula, and I'll label it, to find the answer to the problem. I'm going to factor it by trial and error, and I know that 3 times 2 is equal to 6, and I also know that 3 plus 2 is equal to 5. So I'm going to write 3y here like that, and I'm going to write 2y there like that. And if I want to get negative 1, the only way I can get negative 1 is to have a plus 1 and a negative 1. And if I want 3y plus 2y, and I've got a negative 3y, I'm going to need to have my negative sign there, my plus 1 there. And that's how you could factor this problem without using the quadratic equation. If you multiply this out, you're going to get the original result. I'll keep going for the answer. So the answer is if this thing is equal to 0 or this thing is equal to 0, then that y that gets us to that result is the answer. So negative 3y plus 1 is equal to 0, well then y must be equal to negative 1/3. And if we have 2y is equal, or excuse me, 2y minus 1 is equal to 0, then y is equal to 1/2. And so my answers are y is equal to negative 1/3 or y is equal to 1/2. Both these solve the equation. Well, I can see right away, because I'm plugging it in, that I made a mistake over here. It should be y is equal to 1/3. When y is equal to 1/3, then we get negative 1 plus 1, which is equal to 0, and y was equal to 1/2 as well. So I almost made a mistake, but I caught myself. Now let's go to ALEK's and make sure that I've done this correctly. So here we are. It said if there is no solution, click on no solution, but if there's more than one solution, separate them by commas. So I have 1/3 as one of my answers. I'll write a comma in there, and 1/2. And I'm using my keyboard to navigate along. Now, ready for the moment of truth. Let's click the check button and see if I got the answer correct. And happily, I did.